All right, I'm going to talk about work done by a variable force. The reason that these notes are separate from the first notes about work is that depending on exactly the timing of what you're covering in your calculus class, you might not know how to handle this at the same time as you can just do the regular old work done by a constant force. So we know that if force is constant, then work is equal to force times distance times the cosine of the angle between them, in case they're not pointed the same way. But once we have that, that force that's in the right direction, same direction as the displacement, we could consider a force versus position graph. And if the force is constant, then there it is. And if you want to sort of visualize what you're doing when you're multiplying these together, well, multiplication is kind of like finding area, right? It's a force times a distance. So you could think of that force times distance as the area of this. So if force is variable, then it's the same thing. It's still the area. And I think you might have come across this in your notes about spring force also. So maybe we kind of already know this. But in general, work is equal to the integral from one position to the next, one position to some other position, of force with respect to position. And that really is it. I don't have a whole lot else to say about it. And I'm looking at your spring energy notes, and I can see that I've already introduced this idea there. So the only other thing that I want to say is that every once in a while you might come across a graph of acceleration versus position. And I just want to give you a tip here. This tip will help you out with problems, specifically with problems number 34 and 37. In those two problems, you have a graph that is acceleration versus position. And you might be thinking, well, how am I supposed to do anything with that? It's the wrong thing. But if you multiply this, by mass, then effectively all you're doing is like rescaling the vertical axis of this by multiplying by mass, and then of course mass times acceleration. That will turn that graph into a graph of force versus position, and then you can find your area. I'll give you another hot tip. If you have any intuition at all, and you're a reasonably good test taker, which I think probably you are, then you got to think about, like, when you see a graph, before you even realize, oh, this is force versus position, so the area under that is work, and before you even realize that, if you see a graph that looks like super geometric in nature, like this, it should at least cross your mind, like, that looks like the kind of thing that I could like find the area under pretty easily, because it's all like triangles and rectangles and trapezoids and stuff. So you just want to be on guard for that, and then if you realize, oh, it is in fact a force versus position, then you're going to be led in that direction anyway. So that's a hot tip for you. How about that? 5-minute notes. Woohoo!